Okay, so here is our part 2 of the review on the midterm, and this is going to be on page 20, or not page, but problem number 29. We're going to do these problems, and then we're going to do a few more on the bottom, which talks about something else. So notice right here, it says find the roots, the y-intercept, and then graph. So if you notice, this is cubic, and the 131, 30, and 32 are quartic. So we're not no longer in the world of parabolas, we are in the world of other looking graphs, right? So roots. We're going to find them just like how we would with quadratics, just we have a few things that we need to do first. So first, like always, we check for the GCF. So I look at all three of these, and what do they have in common? They all have an x in common. So I'm going to factor out an x, and I'm going to have left x squared minus x, that's going to be minus 20, is equal to 0. And if you notice here, now that we factor out the x, now it looks like a quadratic. So we're going to do the exact same kind of factoring that we've normally done, right? The crisscross method. So x times x is x squared, and negative 20, what multiplies to negative 20 and adds up to negative 1? Well, that would have to be negative 5 and 4. So we're just going to check this out. X times negative 5 is negative 5x. X times 4 is going to be 4x. When we add those together, we get negative x, so which is exactly what we want. Please note that when we are copying these down, that you do need to go across. Let's see if I can get these right. Oh, that's a tinier one. So this is going to go over here. So this doesn't really matter if your a is equal to 1, but if this number in front of x squared is anything larger than that, then it's going to make a difference. So here we go. So this is going to be x minus 5. This is going to be x plus 4. Do not forget about this x on the outside that we factored out in the beginning. That's what that's going to be. And then again, equal to 0. So again, since we're multiplying these three factors, just like how we did with parabolas, we are going to set them all equal to 0, including the one that's outside here. So x equal to 0, x minus 5 is equal to 0, and x plus 4 is equal to 0. So now that we have that, we're just going to solve for them. And we know that x is going to equal 0. Oh, I didn't put in the 0 there. So x minus 5, so we'd add 5 to both sides, so that's just going to be 5. And then this is going to be negative 4. So these are our roots right here. I should probably label them roots. All right, so what does that mean on the axis, or on the graph, I should say? Actually, let me take those out. I will go to shapes. Oh, probably want this XY. Oh, there we go. See how it's so nice and neat. Let me make that the color black. There we go. And then we're going to put our roots right in there, 0. So 1 right here at 0, 0, at 5 there, and that negative 4. So that's what it means to be roots, right? They're on the x-axis. And now we don't know which way the arms go. It also says to find the y-intercept, but we already know that the y-intercept is right here, right? Y-intercept is doing double duty. It's both a root, and the y-intercept, it does both because it's both on the x and y-axis. So let me just write this down. Y-intercept is 0, right? And the reason why we know that is if we were to plug in this, the 0 in for x here, all we have left is 0. We don't have anything else. So that's why we know that it's going to be 0. All right. So what I ask myself when I'm graphing these things is which way the arm goes. Let's go with the positive side just because that's a little bit easier to think about. So if I have a really big number like positive 1,000, right? And I use that in class as well. So if we use 1,000, 1,000 to the third power, that's 1,000 times 1,000 times 1,000. Is that going to be positive or negative? Well, if we're multiplying by a positive number, there's no reason for it to be negative, right? So it is going to be positive. So as we go to the right on the x-axis, the y is going to be some big positive number. So we know it's going to be up here. So we're going to go through the root. We got to go back to the root and the y-intercept is both of them, right? And then we're going to go back down to cross right here at -4. So this is just a regular kind of cross. It's crossing just regular, and that's not being cubic or anything like that. Okay, and it looks something like this. How high and how low it is, okay, that's not what we're interested in right now. I want to know the general shape of this graph. That's it. All right, and so that's what we would do. If you take a look at number 31, and I remember 31 was 30 was a little bit different, so I'm going to just hold off on that. And so practice again, press pause, try it out first, and then and if you can't get it, then practice again, and then just press play. All right, so let's try to do this in a different color. No, let's try to keep it the same. So let's go roots again. So make sure when you're doing this, please mark down like what you're doing so I can tell what it is that you're trying to solve. So if you look at this, I'm looking for the GCF, and the GCF here is again x. So this is going to be factor out that x squared plus 5x plus 6. And we're going to do some factoring here. So this is x times x. And what two numbers multiply to 6 and add up to 5? 3 and 2. It's definitely not 6 and 1. It could subtract to 5, but notice we have no negatives on here. So we know it can't be that because it would have to be 6 plus 1 because we're not using negatives. So that wouldn't work out. All right, but you could always try, and then you can find out, oh, it doesn't work. Right, so 3 times x is 3x, and x times 2 is 2x, and yep, this is equal to 5x. It's just good practice to do this. If you can figure it out from here, if you can go straight to the factored form, that's fine as well. So this is going to be x plus 3 times x plus 2, and that's going to equal 0. Again, since we're looking for the, what is it called? Since we're looking for the roots, we have to set them equal to 0. So again, this is going to be x is equal to 0, x plus 3 is equal to 0, x plus 2 is equal to 0. I know some of you guys might be able to just figure out the roots from here, but please show this step because this is important, okay? Because I want you to make sure that you understand that the reason, we're not just setting equals 0, we're not saying, oh, x is equal to -3 just because. We need to actually like show the reason why behind that, okay? So this is I'm setting up the equations, and from there, you're going to be like, well, 0, -3, and -2. You don't really need to show your work there. I'm going to assume that you know that you're subtracting 3 on both sides and all that kind of stuff. Or you could, I guess you could think in your brain, okay, what plus 3 will give me 0? Well, -3. So like either way you're doing that, that's okay. Okay, so we have, again, our graph. Let's go with this again. Just a little lower. And we're going to take a look at this guy right here and make that black. Just like how we did before. And our roots are going to be at 0. Negative, so here's -1. Here's -2. Try to make them about even as you can. -3, so here's my root at -3 and at -2. There are no multiplicities, right? So we're not going to be doing any like parabola bouncing off kind of thing, right? They're just going to go straight through, just like how we normally would. The y-intercept, again, we do cross the y-axis already at 0, so our y-intercept is 0. Okay, so that is one and the same. Alrighties, and so we're going to graph that line, and I would like to tell you that, make this just a little bit separate so that it's funny that they kind of merged them together, right? I don't want that. So if we take a look here, I'm going to ask myself again, well, what if this was a big positive number, right? 1,000. I like to pick 1,000. Easy to say. So 1,000 to the third power, is that going to be positive or negative? Like, oh, it's going to be positive. So we know that the arm is going to be up here in this, where x and y are both positive, right? And if it ended up, if we were like, oh, well, y would be negative, then we would say negative. And some of you guys may wonder, well, when would it be negative, right? Oh, that's not very good. Let me try this one more time. Ah. Okay, there we go. All right, so we're going to go right here. Go down, go up, and down, just like that. That's going to be our, what is it called? A parabola, not parabola, oh my dear. That's going to be our polynomial, right, our cubic. And the way that you would get this to be negative, right, like, because you must be wondering, maybe you're not wondering, but when would this be, when would it be negative? When would this arm go down? So if we had on this equation, if we had a negative on the outside of that x cubed, so it looks like this. So this is when it would be. So if I were to ask you, well, if x is 1,000, what would the y be? So if we put 1,000 to the third power, that's like a really big positive number. But then we have this negative on the outside, which means that it does become negative. So when you have that, it does flip around and it just does the exact same thing, except it's going in the reverse order like that. So if this was a negative on the outside there, that's when that would happen. I wish I had an example of that, but apparently I didn't. Sorry, my bad. All right, so that's when that would happen right there. And then let's try the next question. So this is going to be 32 and 30 and 32. So if you take a look at this again, oh, we're looking at the GCF and we're like, wait a minute, we don't have a GCF. There's nothing there. Some people may try to be like, oh, well, I can take out an x squared, right? Because these two have x squared. And then you'll be like, x squared, and this is x squared left minus 9x, no, not 9x, just minus 9. And then plus, and this would be 18 divided by. So yes, we did factor out the x squared, but now we have this x squared on the bottom. Doesn't work. So we can do that, but we're not going to be able to solve anything. So therefore, we're not going to do that. So let's try a different way. So let's try to just factor, okay? So what times what will give me an x to the fourth? Well, we can think x squared times x squared, right? That will work. And then what two numbers multiply to 18 and add up to negative 9? Like 9 and 2, that doesn't work because we have 9 in there. And then 6 and 3, okay, 6 and 3 work. And both of them have to be negative to make that negative 9 right there. So when I multiply these two guys, that becomes positive 18. And then when I add them, negative 9. So this is my check. Oh, this is going to be negative 6x squared. This is going to be negative 3x squared. And notice right here, this is going to be negative 9x squared, which is exactly like that. So the x squares work out. Happy days. This is what we call quadratic form. It's in the form of a quadratic, but it's not quadratic. But we can treat it like kind of like the same. And then from here, we're just going to go straight across. So again, this is going to be x squared minus 6. And this is going to be x squared minus 3. That equals to 0. Just like how we did before, we're going to set those two factors equal to 0. So it's going to be x squared minus 6 equals to 0. And x squared minus 3 is equal to 0. Now this is a little bit harder to solve because we have these squares in them still. So I'm just going to do the work here. So normally we would just add 6 to both sides. So we get x squared is equal to 6. And how do you get rid of the square? Do the square root. All right, we're square rooting both sides. So you're going to get x is equal to, don't forget your plus or minus, square root of 6. Remember, whenever we're dealing with a square, there are two numbers that it's the positive side and the negative side. All right, so that's our first answer. For our second answer, same idea. So x squared is equal to 3. And then we're going to square root both sides. So that's going to be plus or minus square root of 3. That's what x equals to. So to combine this, we're just going to say plus or minus square root of 6 plus or minus square root of 3. If you want to write them out like 6, a square root of 6, comma, negative square root of 6, comma, square root of 3, comma, negative square root of 3, that's okay. But this is a little bit more succinct. Okie dokie, and now we're going to go into our graphing. Oop, let's not make it too big. I think that is fine. Come, go up. It won't let me go up. I'll just do this. Oh, it won't let me do anything. That's so weird. You see this, right? It's not letting me do anything. Okay, There was a little bit of an issue, sorry. And just delete that. Oh, like literally won't let me do it. Never mind. Okay, we'll make that black graph just like that. Okie dokie. And so we're going to put on, so now, well, where is the square root of 6? Right? I know it's going to be on the right positive, but where exactly is that? It's going to be like less than 3, because 3 times 3 is 9. So we're going to take our calculator. And here we go. We're going to be like, okay, square root of 6. So that's going to be about 2.4. And then square root of, what is it called again? Square root of 3. So square root of 3 is going to be 1.7. So 2.4 and 1.7. We don't need to round that many times or that much, just because, you know, 2.4 and 1.7. I believe that's what it was. So this is about 2.4. This is 1.7. This is plus or minus, plus or minus. So we're going to go over here. So here's 1, 2, 3. So about evenly spaced. -1, -2, -3. And so here we go. -2.4 is -2. So a little bit less than halfway. And then over here, 2.4, so a little bit less than halfway. So notice the distance it has to be about equivalent. And 1.7 is going to be over here, so closer to the -2. And this one is closer to the +2. So those are going to be our 4 roots, just like that. And then we need to figure out, well, which way does it go? Where are the arms going, right? And so again, I'm going to ask myself the question, x to the 4th power, if it is a big positive number like 1,000, right? 1,000 to the 4th power, still going to be positive, right? So we know that in our, oh, wait, I forgot something. I forgot our y-intercept. So let's talk about y-intercepts first before we get into that. Hold that thought, right? So remember when we put 0 in for x, this becomes 0, this becomes 0, right? Because it's 0 to the 4th power, which is still 0. 0 to the 2nd power is 0 times 9, still 0, it doesn't matter. So all we have left is this 18, just like how we do for the quadratic, right? It's the same kind of idea. So 18, this is not to scale, so I'm going to just call that 18 and call it a day. All right. And so I know that it's going to be up here. It's going to cross here. So let's just try. Let's just not ask that question of like, oh, if it was positive, if it was a negative. Let's just try. So let's try it down here. Let's see if it works. So I'm going to cross and I'm going to cross. But now how am I going to get to the 18? I literally can't. Like, I can't cross here because it's like, boom, rejected, boom, rejected. Like, we can't go any of these places because the only places we can cross, or maybe the only place that there's a door, all of these are walls, if you want to think about it that way, are at these 4 places, and the only other door over here is this place. So we literally can't start in this room. It's not a thing. So we can't do it. It doesn't work out. Ew, I should put back my number. All right, now let's try then starting from this first quadrant right here, right? So we're going to go down. Oh, that's not good. Go down and go up. And then, oh, yep, now we can reach that. Is that where the maximum is? I don't know. We're going to go down and we're going to go up, just like that. Look, it looks like a W. What does it actually look like? You can try it on Desmos. Let's try it on Desmos, actually. Where's my Desmos? Right here. So let's try this one out. This is going to be x to the 4th minus 9x to the 3rd plus 18. Ooh, it's not x to the 3rd. No wonder it looked weird. I'm like, why are the arms like that? There we go. So let me just zoom in just a little bit and notice right here on the y-axis, it's 18 right there, just like we said it was going to be. And yep, and that is actually the highest point, or so it's the relative maximum, right? But yep, do you see how it looks like the W? Right, there we go. And oh, let me just check the roots real quick. So if you look at this, yep, 2.4, 1.7. We did a good job. All right, so that's what that looks like. And going on to the last problem right here for this kind, for number 32, here it is. So again, if you notice right here, we always check, is there a GCF? And yes, there is. In this case, it's x squared. So it's going to be x squared. Yeah, you know, let's just do this other color. So x squared, factor that out. So all we have left is another x squared minus 8x plus 16 is equal to 0. So again, press pause, try it, and then press play. Or move if you like totally got this, you're like, Miss Lee, I totally got this. Then move on to the next part. Don't let me hold you back. All right. So there we go. So this is going to be x and x, and this is it's not 8 times 2 because it has to equal to an 8, so that wouldn't work. 4 times 4, that would work. So 4 and 4, and they both have to be negative because it has to add up to a negative 8 and multiply to a positive 16, right? So here, that's going to be negative 4x. Just checking. This is going to be negative 4x. So this is going to be negative 8x. So this is going to be, in factored form, x squared times x minus 4 times x minus 4. I mean, technically, we can say x minus 4 squared because we have it twice, but we're going to have to parcel them out anyway, so it doesn't really matter. So here we go. So we're going to have x squared equals 0, x minus 4 is equal to 0. We kind of actually have that 2 times, right? So what is my roots going to be? So it's going to be x is equal to, well, 0, we'll normally square root both sides, and we get plus 0 and minus 0, which is still 0. But we have it 2 times, so it's called, remember what's called a multiplicity of 2. Okay, and then we have this one, x would normally equal 4, but it happens 2 times, right? See here, x is equal to 4 here, x equal to 4 here. So that's why we also say this is a multiplicity of 2. So we have 2 of them with a multiplicity of 2. So what's going to go on? Going to be bouncing off, okay? So here is our, ooh, there we go. Come on, work with me. There we go. There's our graph. And then we're going to use, let's use this one. Oh, our purple for our roots. So at 0, it's going to cross there. Or not cross, it's going to just bounce over there, and then multiplicity of 4. So here's my 4. And it's going to bounce off of there. And if you notice, what do we notice? Oh, we don't notice anything. Oh, well, the y-intercept is at 0. So that's not going to really help us like it helped us in the previous problem. Y-intercept is just 0. So not helpful. What do we do then? Remember, we're going to look at the x to the 4th, right? The first term. And we're like, okay, if x is positive, 1,000, a million, a billion, whatever it is, then it's still going to be positive. So we know we're going up from here. Arms are up. Oop, try this again. So arms are up. It's going to reach 4, but then what's it going to do? It's not going to go through. It's going to bounce, just like a parabola. We have to turn back down because we've got to cross this. We're just going to bounce just like that. Oh, that's supposed to look like a W. It's a really weird W, but yeah, that's what it should look like. There should not be a little square thing. It's a line that goes like this. All right. So that's what it should do. Right at 0 and 4. All right, so we're going to move on. Go down. Oh, too far. Go very carefully. Creating equations. So this is the part where we're going to create equations. Move it just a little bit. Remember, for these ones, technically, we're not writing these in standard form. It's either going to be in vertex form or factored form. These are the two that we would be writing them in. So factored form and vertex form. So factored form, what that looks like, if you remember, is the parentheses, right? So it's literally going to be f of x. I'm trying to color coordinate them here. So factor is going to be a times x minus r1, x minus r2, where r1 and r2 are just basically our roots, right? So those are our roots, which we've talked about this before, right? So whenever you see something with roots, if they give you roots, you're gonna do factored form. If you have a vertex, right? they say we have a vertex. That should be like ding, 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 use vertex form, right? So we're going to do that. And vertex form is going to be f of x, oops, is equal to, so f of x is equal to, what is it equal to? A times x minus h squared plus k. There we go. And then we're going to, so h and k, so the vertex, so just as a quick reference, is hk. Okay, so there you go. So if you look at 57, it says, write the function of a graph of a parabola that has roots at 4 and -2. So automatically roots, I'm like, okay, orange, roots at 4 and -2. Okay, so these are my two roots, right? It doesn't matter which one is R1, R2, that it don't matter. And opens down. So opens down refers to our A. Remember our A? Because if that A is positive, it opens up. If it's negative, it opens down. That's what that is. So that A is this guy right here. So this is A, which is the same A as this. It's the same in both contexts. Okay, it doesn't change. All right, so here we go. So let's write this down in orange. So this is going to be f of x is equal to, it's opens down, so I'm going to make that negative. -1, I don't need to write down the 1. Negative, and then x minus, do you see? Okay, so now I'm going to plug in those roots and I'll be like, okay, here's 4. So it's just x minus 4. And if you remember, if we set it equal to 0, right, and we solve, we would add 4 to both sides, right? And then so you would get x equal to 4, which is right here, positive 4, right? So this one is -2. So again, this is supposed to be a minus, so -2. That minus and negative, make it a plus, right? And then so this would be, there it is, we're done. We wrote the equation. Okay, and just as a quick check, let me just show you how we know that. I'm just going to write this in here for you. So this is going to be negative x minus 4 and x plus 2. And what do you notice? It is open down. See? Ah! And look right here, root is at -2 and at positive 4, just like what we said. It's magic. All right, and so it says write the function of a graph of a parabola that has a vertex. Ooh, vertex. Use this color. Vertex of -3, 1. So automatically we're using the vertex form, and it opens up. So we know it opens up, which means we're dealing with A is equal to positive 1. So here we go. F of x is equal to A, which is positive. So I technically don't need to write anything in there. I just, if I don't put anything in, it's automatically assume that it's positive, right? And so it's going to be x minus squared. Okay. And I like to write in the rest of the stuff later. So here it is. Here's my h, which is -3. Did you see that? What I did? -3, and then plus 1, because that's a positive. There we go, vertex form, just like that. All right, so let's try the next one, 59. It says write the function of a graph of a parabola that has roots at -1 and -9 and opens down. So there we go. Roots, orange. There we go. So here's roots, -9, -1. And so this is going to be f of x is equal to opens down. So, oh, this opens down. So we got to put in that negative right there. Negative. And this is going to be x minus a -1, x minus a -9. Do you see how that goes? I'm not doing it in different colors now. We're upping our game. Okay, guys, we're upping our game. There we go, just like that. All right, and this one, it has roots at these fractions. Now, what am I going to do with that? To make it look nicer, this is what we're going to do. We're just going to set these equal to x. This is like our final answer, right? We're going to kind of like go back in time, right? What did these look like before we got to this, right? We got to this point. And technically you could do that with these other ones, like the integer ones, but it gets a little bit more, but it's not as hard for that one. These ones are a little bit more complicated. So I could show you like an algorithm, but I'll tell you this is why it works. Okay, so what we're gonna do here is we're gonna be like, okay, how do I get this to be divided by 3? Well, I probably multiply, well, it was probably multiplied by 3 before, so that I could divide it by 3, right? We're like reverse engineering this thing, right? So I'm gonna just multiply by 3. And so then probably the step before this was 3x is equal to 2, right? And then, so remember over here on the right, we always set it equal to 0. Well, how do I get it equal to 0? Well, that's going to be minus 2. So then I would get 3x minus 2 is equal to 0. Now, the 3x minus 2, that is the thing that we're setting equal to 0, right? When we have it in factor form, we're like, oh, set them both equal to 0. 3x minus 2. There we go. Right? Same thing we're going to do. We're going to do the same thing to the right-hand side. So that's going to be, we're going to first, okay, it was probably multiply, right? Oop. Multiply by 9. And then it's going to be 9x is equal to negative 4. And we're just going to move that to the other side. So add 4 to both sides. And I don't know if you knew that you could do this, but yeah, this is a thing. Quite often, when I was in high school, I would ask my teacher for like help on stuff like that. And then when they did it, I was like, oh, well, I knew that. I didn't know you could do that though. And so that was often what was going on with me in high school. So it would be f of x is equal to, let's see if I can fit this on here without messing it up completely, is equal to, remember it's opens down, so that's negative. And then my two factors is 3x minus 2. And this is going to be 9x plus 4. Ooh, I got it in. It worked out, right? So that's what that would look like. We are almost done. We have 3 more problems. So if you made it this far, good job. We do well on the midterm. Yes, do well. So now we don't have the help of the formulas. So hopefully you wrote them down because I'm not scrolling up and down again. So it says right here, find the vertex or find the function of a graph of a parabola that has a vertex. Ooh, vertex, this one right here. Vertex of 5, negative 3, and opens down, right? So we know what that means, negative, right? So that's going to be f of x is equal to, we'll pause. Did you do it first? Okay, it's going to be negative, and then x minus 5 squared. Don't forget the square. A lot of people forget that. If they're going to forget something, they forget the square. Minus 3. And it's minus 3 because that's a negative 3. Done. Next one. Write the function of the graph that has a parabola that has roots. I said that weird. Roots here. Right? So one of them is pretty easy to do, but the other one is 1.4, right? We would like them in regular numbers, so I'd like to, 1.4 is like 1 in 4, so 1 in 4/10, right? And so 4/10 is like 2/5. It's not like 2/5, it is 2/5. And then I'm going to just change that to a mixed fraction, I mean improper fraction. So that's going to be, it's going to be 7 over 5. How I know that? This is how I learned it. So 1 times 5 is 5. And then plus 2 is 7. So we have 7/5. But the more like conceptual way of doing that, because that's just an algorithm, like that doesn't like, you're like, well, why? Why do you multiply? I'm like, well, just because it says to multiply. But if you think about it, right, if we have 2/5 here, we're going to take this 1 and we're going to cut that into fifths as well. So how many fifths would we have to make one whole? Well, 5, right? That's 5/5, right? So it's 5/5 plus that 2/5, which is going to give us that 7/5. Okay, so that's what that's going to look like. And so we're going to, I'm just going to set up this one right here. So x is equal to 7 over 5. And we need to do like what we did for that previous problem that's right above here. And we're going to just multiply both sides by 5. And then we're going to, so that's going to be 5x is equal to 7. And then we're going to get rid of the 7. So we got to subtract it, right? And then this is going to be 5x minus 7 is equal to 0, right? So there's that factor. We know the other one is just x minus 5. I mean, honestly, if you want to do it the way we did it for the fraction, like, okay, x equal to 5. So now what? How do we get rid of the 5? We subtract 5. See, that's the same thing. And then it's going to be x minus 5 is equal to 0. Yeah. So unnecessary to do in simple numbers like that when it's just integers. But when it's these fractions, it's a little bit easier to. And once you get the pattern down, you could probably, you probably don't have to show this working and do it, but it's a good way to check just in case, because sometimes I get those wrong in my brain. So again, so it's f of x is equal to, and it opens up, so it is positive, so I'm going to just leave it like that. So it's going to be 5x minus 7 times x minus 5. There we go. Answer right there. And it says write the function of a graph of a parabola that has a vertex of 9.2 and 13.1. In this case, when we have vertexes, a vertex, that is with these decimals, we're just leaving out the decimals. It's only the factor one that we do that for. Okay, so it's going to be, and you're probably like, oh, phew. I don't even want to try that one. All right, so f of x is equal to, it says opens down, right? So this can be negative x minus 9.2 squared plus 13.1. Yay, done. So again, if you have questions, this was part 2 of the review for the midterm. If you have questions on the first part, then do those. I included a whole bunch of problems where you can, if you look over here, where you can just solve for quadratic. If solving for x was like the hard part for you, I have a whole bunch, like do these or these, right? And it kind of gives you a hint. It tells you like, oh, using the quadratic formula here, oh yeah, using quadratic formula right here by taking the square root, right? So notice we only have one variable here, so you're going to have to just get everything on one side and then just square root them, right? So this is a good way to practice that if this is something that you weren't that strong on. All right, I hope this was helpful. I will see you later.